In this video, let's see numerical methods. That is, we are going to see finite differences. So in that, the first topic is forward and backward interpolation formula. So first of all, why we need to learn about this? For example, they have given a set of values x and corresponding f of x. And say for x is equal to 0, the value of f of x, let it be 6. For 4, let it be 15. For 5, it is 17, something like that. It's going on. So till we have say 10, for x is 10, the corresponding y value is 40. For example, if I have to find some value, say for corresponding x is say 2.5, what could be the y value? So by the existing values of x and the corresponding values of y, I can find out this particular value of y when x is 2.5. So if I have to find that is f of 2.5, we call it as an interpolation. So extrapolation means, for example, for say 15 or closer to it, 11.5 or something, I'm going to find the corresponding y value when x is 11.5. So towards the end or after the value, then we call it as an extrapolation. So we have interpolation formulae for equal intervals. Okay. So equal interval means, for example, see this problem. We have x values 0, 1, 2, 4 and the corresponding f of x, or you can say it as y. Both are same. Y values 225, 238, 320 and 340. These are the x and y values. Now you have to find the value of y when x is 0.5. It is nothing but find y when x is 0.5. So, we have to find x at 0.5 means first thing you have to check whether it's in the beginning, near the beginning of the table or at the end of the table. So where this 0.5 comes, it comes somewhere in between. Okay. So it is near the beginning of the table. So what we are solving now is by using Newton's forward difference, because the value that we have to find, that is x is equal to 0.5, is near the beginning of the table. So we will use Newton's forward difference. And we can apply this technique when there is an equal interval. See the x value, first value is 0, second value is 1, the difference is 1. Then third value is 2, difference is 1, right? And the next value should be 3. Sorry, I have written 4. The next value should be 3. Okay, so now the equal interval should be there, then only we can apply Newton's forward difference. So check whether they are at equal intervals and then find whether the point lies in the beginning or at the end. And this is the formula for forward difference. Y naught plus r into del of y naught. This is the notation for forward difference, del, plus r into r minus 1 by 2 factorial into del square y naught. Can you guess the next term? Plus r into r minus 1 into r minus 2 by 3 factorial into del cube y naught and so on. So where r is nothing but x minus x naught by h. So what is this x naught? The first x value is x naught. X naught is 0. Now let us form the tabular column. Okay. So let the x values, first I will write it first. Okay. So x values I will write. So x naught is the first value, that is 0. x1 is the second value, that is 1. x2 is the third value, that is 2. And finally we have x4 as 3. So I have written all the x values. Now, oh my god. Now I'm going to write y values. So now I will write the corresponding y values. So first value is nothing but y naught. Okay, 225. Second value is y1, 238. Third value is y2. that is 320, and fourth value is y3, that is 340. This is what given. Okay. So remember we wrote del y. So that is going to be your first difference. So to find del y, I have to subtract, always this is a thumb rule, second value minus first value. That is 238 minus 225. So this is nothing but 13. So I will write this here. Then second difference is 320 minus 238. So I will write this as 82. Third one is 340 minus 320. That is the second value minus the previous value. So this is nothing but 20. This is your first difference if you write del y. Then the second difference is, to finish within this, del square y. So 82 minus 13. Let me write the answers directly. Okay, 82 minus 13. So we got 69, and here 20 minus 82. If you notice there is a negative sign, so please be careful. So the second value is minus 62. So you have minus 62 and 69. Now we are going with the final tabular column, that is del cube y. Here, when you write second value minus first value, what you will get? That is minus 62 minus 69. Okay. So this is nothing but both the negative values are there. So it means we will add and put the negative sign, minus 131. So this is the final value. So please be careful with the sign. 20 minus 82 here. Because of the smaller value, we got negative sign here. So here the next step is minus 62 minus 69 we got. So which is nothing but minus 131. So this is your tabular column. We got x and y from the question, and then this is first difference, this is second difference, and this is third difference. Now finally we are going to substitute these values in the formula. And remember, in the formula we need y0. Y0 is here, and this 13, that is the first difference, is del y0. And the second difference, that is 69, is del square y0. See the topic, the heading is del square. And minus 131 that we got here, right? This is nothing but del cube y0. Minus 131 is del cube y0. I will rewrite these values again. So del y0 is your first value in your tabular column, that is 13. And del square y0 is again first value in the next column, that is 69. And del cube y0 is equal to minus 131. So we are taking all the values which is there on the top of the tabular column. That is, this is the first y0, and this is second del y0, and this is del cube y0, and this is del power 4 y0. So I have written this. Now we have our formula. We have to find r. R is x minus x0 by h. That is x minus, what is your first x value? 0 divided by h. H is the difference between all the x values. What are those? 0, 1, 2, 3. The difference is 1. So that is what it says. So x minus x0 by h. So now we have to find for the corresponding x is 0.5. So 0.5 minus 0 by 1, that's equal to 0.5. This is your r. Now in your formula, you will write f of 0.5, or you can write y at x is equal to 0.5. Both are same. So we'll go back to the formula, that is equal to f of 0.5 is equal to, what is the first term in your formula? Y0. Y0, you can check the tabular column, it is 225 plus r into delta y0. R is 0.5. Just now I calculated. Here r, delta y0, what I wrote? It is nothing but 13 plus r into r minus 1. 0.5 into 0.5 minus 1 by 2 factorial into delta square y naught. Delta square y naught is 69. Then one more term, let me write it here, r into r minus 1 into r minus 2 divided by 3 terms are the 3 factorial and into this corresponding values minus 131. So if you simplify this carefully, you will get the answer is 214.6875. So this is the corresponding value of y when x is 0.5, which you can see here. Okay. So in the next video, let us see backward difference formula.